Okay, so now what we want to do is we want to look at how to graph quadratic equations. First of all, we're going to look at vertical shifts, but hopefully I'll be able to introduce that without getting too technical. First of all, a quadratic equation in general is anything with a squared term in it. So we might have something like, this is kind of your most basic quadratic equation, y equals x squared. When we graph that, it's actually going to look like a parabola. We can prove that actually by making a little table x and y. So let's start filling out the table of x is -2, -1, 0, 1, and 2. Okay. So now if we plug this in, so we have y equals x squared, so that's 4. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So this means that we have the points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So I'm going to go plot these. 1, 2, 3, 4. Okay, so I've got -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Okay, so this is my basic shape for a quadratic equation. So y equals x squared. So throughout this whole process, we're going to start with this basic shape. And I'm actually going to pretty much simplify it. The only points I'm going to draw are here, here, and here, and then I'm just going to go like that. Okay? So you'll notice you've got a point at 0, 0, and then you go over 1, up 1, and then over 1, up 1, and then it's a loop from there. Okay? So that's what we're going to start off with. Okay? Now, let's take a look at what if I have a slightly different equation. What if I have x squared plus 2, for example? Well, now, if I do this, I'm just going to do -1, 0, and 1. Okay? So x squared is -1 squared plus 2, so that'll give me 1 plus 2 is 3. 0 squared plus 2 is 2. And 1 squared plus 2 is 3. So my points are -1, 3, 0, 2, and 1, 3. So I'm going to draw this and plot my points. I have -1, 1, 2, 3, -1, 3, 0, 2, and 1, 3. So my new graph now looks like this. So the question is, well, what happened to this graph? If we think about what it looked like before, it looked like this before. So what's different about it? So if we look at the equation, this is a plane equation. It was centered at 0. Now we see if we have this equation that actually our graph has been moved up 2 points. Choop, choop. Okay? Ooh, come back. Has been moved up 2. So we can assume that this would hold in general. That when we add 2 to any kind of a quadratic basic form, that we're going to shift the vertex up 2. Now I just snuck in a vocabulary word for you. This point here is called the vertex. Okay, so the vertex is the point that it kind of originates from, is I guess one way to think about it. That's the vertex. While we're at it, let me go ahead and give you another vocabulary word. And this is the axis of symmetry. Alright, so the axis of symmetry means that it's, well, symmetric. Like you could fold it across that dotted line and it would be perfect. The equation for this axis of symmetry is x equals 0. The vertex of this one here is 0, 0. So you'll notice when we do a vertical shift, which is what we did, we moved it up, we now have a new vertex. The vertex is now 0, 2. The axis of symmetry is the same, so that's good. symmetry, and it's x equals 0. Okay. Now, we're actually going to get the same thing, as you might suspect, if I give you a slightly different equation. I give you x squared minus 3. So what do you think is going to happen there? So if you have some time, which you obviously do because you're sitting here watching this, go in here and figure out what your points are, and then go plot them and see what happens and see if that's what you expected. Okay, so theoretically you should pause this and go try to do it on your own. Assuming you did that, we have negative 1 squared minus 3. So 1 minus 3 is negative 2. 0 squared minus 3 is 0 minus 3, or negative 3. And 1 squared minus 3 is 1 minus 3, or negative 2. So we have negative 1, negative 2, 0, negative 3, and 1, negative 2. So we have negative 1, negative 2, 0, negative 3, 1, negative 2. And then here is our beautiful little parabola, looking something like that. So what happened here? Well, as you remember, your base looked like this, right? So all we did is we shifted it down. We shifted it down 3 with an exclamation point. The axis of symmetry is still the same thing. Oh, symmetry is still x equals 0. But the vertex is now 0, negative 3. And actually this applies to everything. If I give you generic, y equals x squared, minus 27, then you don't even have to really calculate the points. You can just say it's going to go down 10, 15, 20, 25, 30, I don't know. So there's 27 or something like that. Here's 27. The point goes down here at 27. So 0 minus 27. The next one is going to be over 1, up 1. 0, negative 26. Over 1, up 1. Sorry, not 0. 1, negative 26. And negative 1, negative 26. So you can see that you've got over 1, up 1, over 1, up 1, and I don't even have to really pay attention to it, but there's my whoosh, giant graph. The axis of symmetry is still right down the middle, and then this is my vertex. So the nice thing about these is that if you can get it into this format, whatever's on the end is your vertical shift, either up or down, and that's going to tell you where that vertex is moved to.